In order to talk about function operations, I want to start back with something that we should know how to do, which is adding polynomials. When we add polynomials, we look for like terms. So, for example, 2x squared and x squared are like terms. When you add them, you get 3x squared. 3x and negative 8x are like terms. When I add them, I get negative 5x. And negative 5 and negative 2, which are both constants, are also like terms. When I add them, I get negative 7. Well, now I'm going to change this problem just slightly, and I'm going to say f of x equals 2x squared plus 3x minus 5, and g of x equals x squared minus 8x minus 2. F of x, that's how this one was pronounced, and g of x were just other representations for y. They're the output of a function as opposed to x being the input. They're the name of the function, so we called one of the functions f and the other one g. Well, if I said to you, let's add those functions, I would be asking you to do the same thing we did in the previous problem where we were just adding the polynomials. Because adding, subtracting, multiplying, and dividing functions is the exact same thing as adding, subtracting, multiplying, and dividing polynomials. But the notation is different. So there are two ways of writing addition of functions. Sometimes it's written like this. This is pronounced f plus g of x. And sometimes it's written like this. Both notations mean exactly the same thing. I point out to you this notation. Sometimes students confuse this and think I'm asking you to add two functions and multiply by x. That's not what I'm asking you to do. What I'm asking you to do is take the function labeled f of x, which is 4x plus 7, and add that to the function labeled g of x, which is the square root of x plus x. It doesn't matter which way I write it, this is what I'm asking you to do. And then I'm asking you to add like terms. Well, these are like terms, so you get 5x, and nothing else is like terms, so you just write plus 7 plus the square root of x, and the order in which you do it doesn't matter. Now let's talk about domain. Domain referred to what you could plug into an equation without getting an error message or making the equation undefined. Domain refers only to the input or the x values. There are two things you need to watch out for where there are restrictions on the domain. Those two things are fractions. For example, if you have a variable in the denominator of a fraction, you cannot ever have 0 in the denominator because that would say 1 divided by 0, and we can't divide by 0. The other thing you have to watch out for are radicals, because in the real number system, you can only take the square root of a number if it's greater than or equal to 0. So for the function f of 5x plus 7 plus the square root of x, the domain has to be x is greater than or equal to 0. Because otherwise, the square root of x would give me a non-real answer. Now let's try this again where we subtract the two. Here is one notation for asking you to subtract two functions, and here's the other one. All I'm asking you to do is 4x plus 7 minus the square root of x plus x. Now, when we subtract polynomials, I'm not sure how your previous teacher taught you to do it, but I'm a big fan of changing all the signs in the second polynomial and then adding them together. So here are my like terms. 4x and negative x is 3x, and nothing else is like terms. So this is what you get when you subtract the polynomials. For the domain, since there's a radical, and you can't have a negative under it, x still has to be greater than or equal to 0. Now let's talk about multiplying and dividing functions. Again, because it's just the same as multiplying and dividing polynomials, we've already done that. So one way of writing multiplication of functions is this way, and sometimes we write it this way. But it doesn't matter which method we use. All it's telling you to do is multiply x squared minus 9 times x plus 3. Well, this is something I know how to do. I'm going to FOIL it. I get x cubed plus 3x squared minus 9x minus 27. And then I ask myself, are there any like terms to combine? No, there are not. So this is the final answer. For the domain, there are no variables in denominators of fractions, and there are no radicals. So the domain in this case will be all real numbers. Sometimes we use this symbol to represent all real numbers. And another way that we represent all real numbers is using this. This is called interval notation. It's a way of saying that x can be any number from negative infinity to positive infinity. For division, sometimes we use this notation, sometimes we use this notation. But either way we write it, all we're asking you to do is put f of x on top and g of x on the bottom. Now, we actually know how to divide this. We did this back in another unit. But before I divide it, I'm going to talk about its domain, because the domain is dependent on the original problem before you simplify it. Notice that there's a variable in the denominator. Well, we know that the denominator cannot equal 0. So x cannot equal negative 3. Otherwise, it'll make that fraction undefined. Well, now let's go back and actually do the division. The way that it worked was you would put the denominator, also known as the divisor, outside a little division bar, and inside you would put the dividend, or the top polynomial. Except you had to watch out for missing terms. And notice that the linear term is missing. The next thing we would do was we would find out how many times x plus 3 goes into the first two terms of the dividend. Or in other words, what do you have to multiply x by to make it an x squared? Well, you multiply by x. Then you multiply the divisor by x, and you subtract. This should always go away. 0 minus 3 is negative 3x. Bring down the next term. And then, what do you have to multiply x by to make it a negative 3x? You multiply by negative 3. So you get negative 3x minus 9, and when you subtract these, you get 0. So the simplified version of x squared minus 9 over x plus 3 is x minus 3. However, the domain is that x cannot equal negative 3, because before we simplified, there was a variable in the denominator of the fraction. So, to review, this is just called function notation. All it's asking you to do is to add two functions together. Sometimes students confuse this notation and think that it means to add two functions and then multiply by x. That is not what it says. This is the notation for subtracting two functions. It's just a notation. It just says take f of x, whatever equation you have for that, and subtract from it whatever polynomial you're given for g of x. We can multiply two functions together, and we can divide two functions. All four processes we've learned, because all they do is refer to what you do to polynomials. It's just adding, subtracting, multiplying, and dividing polynomials.